Okay, let's get started. Hello, everyone. My name is Jeff Sale. I work at the San Diego Supercomputer Center, but I am also part of the Exceed partnership, which is really who is hosting this webinar. Forgive me if my voice sounds a little harsh. I came down with a cold last week and was hoping to get most of my preparation for this tutorial done over the weekend, but felt in pretty bad shape and was even considering rescheduling, but I'm going for it because it's not too bad after all. I want to remind everyone to be sure that you mute yourself. We have one of our in-house user support experts, Marty Candace, joining us, and he'll be monitoring the chat, and he will probably mute you if you are not already muted. So don't take it personally. And forgive me if I sometimes am speaking somewhat too concisely, but we are recording this webinar, so Zoom actually does an automatic transcription, and the clearer I speak, the better the transcription. And in that regard, we are creating some really nice interactive videos, versions of these tutorials, which will include an interactive clickable transcript and a searchable transcript and those kinds of things. So we'll send out emails with links to everyone to access those interactive video recordings after the webinar. Okay, first we want to discuss the Exceed Code of Conduct. Exceed, being a public institution, needs to be very sensitive to these kinds of issues. So please be on your best behavior during this webinar. Thanks very much. Oh yes, and we really need to know that you've attended. In the Exceed user portal, there is an option when you're logged in to mark your attendance for this webinar. Normally, this is something that I do when we're hosting a webinar when someone else is presenting, and I'll just check the participant list and guess who's who and check them off in the user portal, but I can't do that because I'm presenting. So it would be great if you can log in after the event or any time during the event and look for that checkbox and mark that you've attended. A little bit about me. I was born in Canada, but I've become an American. I've been here for almost 50 years. My background is in applied physics. I also have a master's in learning design and technology. I use that probably more than I use the physics in my job. And I'm also part of the Exceed ECSS and workforce development groups. And I have been involved in the San Diego Supercomputer Center's online Coursera specialization in big data, which is one of the most popular specializations, a series of courses that Coursera has ever hosted. So we're real proud of that. Check it out, it's still available, and it's a 5-course sequence where you can get certified as a data scientist. Of course, the real motivation is my wife and child. And I always like to get a little bit personal. I love the outdoors, it is my healing space. And recently we did the John Muir, sections of the John Muir Trail. For those of you outdoorsy people, you know how amazing that could be. And even on a bad day fishing is still better than a good day working. And I want to acknowledge some folks who are particularly responsible for this webinar even occurring. Chris Myers and Susan Maringer at Cornell were the ones who were originally supportive of the idea of me helping develop a data science with Python tutorial, which is ready to be staged on the Cornell Virtual Workshop. Chris he was the subject matter expert in that effort, and I was more the learning design technologist. But Chris is an outstanding visualization person in his own right. And I'm seeing people are saying they can't hear anything. Now I'm hearing myself because I've got another computer connected to test that. I'm only seeing a couple of people. Yeah, most people can hear. Honestly, I'm not sure how to troubleshoot those issues. Sometimes it's an internal muting issue on your computer. So my apologies. It looks like in general we're good. And then I'd also like to acknowledge Kate Starbird at University of Washington and Jen Zymeke at John Carroll University. Really the thing that got me so excited about doing a webinar like this was the bokeh visualization tool that we've been using to explore Twitter disinformation, bot-like behaviors. And bokeh has turned into just a really valuable tool in drilling down and exploring details of a tweet's lifetime. And I'll be showing some of that in this workshop. And lastly, I want to acknowledge Mary Thomas. Mary just joined the Supercomputer Center. She's been a veteran of the Supercomputer Center for many years, but was at San Diego State University, has come back within the last year and a half. She's completely transformed the user training that we can offer, and this webinar is an example of that. And I'd also like to acknowledge Bob Sinkovitz, who's been really supportive of the work that we've been doing. Okay, so the Jupyter project. This tutorial is focused around Jupyter notebooks and doing visualization within a Jupyter notebook. The Jupyter project consists of several different things. It's kind of a rather large menagerie of applications, including things like IPython and Jupyter Hub, and you'll see down there in the middle bottom, they actually include a reference to Bokeh on their website. Excuse me. And then to give you an idea of how daunting this webinar might be to give, this is from a video tutorial given a couple of years ago by Jake Vanderplas, and I want to give a shout out to him. It was an excellent video, and even though it's 2 years old, this is still pretty relevant. You'll be able to see matplotlib here in the middle right, and then Bokeh in the upper middle, and Seaborn is hiding somewhere as well. Those are the three tools. Yes, there's Seaborn right there. Those are the tools that we'll be focusing on for the most part, but there are so many other things happening in the visualization landscape that, you know, the more I learn, the less I know. So forgive me if this tutorial is maybe a little simplistic in that regard. Okay, so what is Bokeh? It's an interactive visualization library for web browsers, basically, that relies on JavaScript. Excuse me, and there's the link. The best way to describe really what Bokeh can do is to demonstrate it. So we'll be getting into that in just a few minutes. But for what it's worth, the word bokeh comes from photography. It is it describes the blurred out lights in the background of a photograph in so many words. Now, bokeh is sort of part of a bigger picture for high performance computing users that sort of is described as HoloViz. If you can go to holoviz.org and learn more about this. HoloViz includes a tool called HoloViews, and that tool really is designed to handle much larger amounts of data than Bokeh itself is designed to use. Now, Bokeh can handle a good amount of data, but and this tutorial is not going to go into a lot of, or we're not going to be demonstrating the use of massive amounts of data, although the data that we will be using for this tutorial is a little over half a terabyte, and the link on the introductory page will point you to the GitHub repo for this tutorial, where you can download all of the data and the notebooks and so forth. Okay, we're also going to be covering a little bit about Seaborn. Seaborn is really, its orientation or its distinction is really to provide a more complex interaction with statistical graphics. And Seaborn will run happily inside a Jupyter notebook. And we'll be demonstrating some of the applications of Seaborn in this tutorial as well. Now, Jupyter Notebook, this really isn't a tutorial about Jupyter Notebooks per se. They've been around for so long that many or most of you probably are already pretty familiar with them, and I'm hoping that's the case. But as we go through these hands-on demonstrations, I'll point out some things that I've learned, but I am by no means, I consider myself by no means a Jupyter Notebook expert. But the TAC Visualization Portal provides access to a built-in interface for Jupyter Notebooks. And you can run anything you need. And typically you should be able to install whatever packages you need within the Viz Portal environment. The San Diego Supercomputer Center's Comet supercomputer supports Jupyter Notebooks through Singularity containers. And the link there points to a webinar given by Andrea Zonka last spring on distributed parallel computing with Python on Comet, and he points to a Singularity container that should serve that purpose. Marty Candace is also overseeing the development and maintenance of a number of other containers, and I believe he's working on getting one functional for Jupyter Notebook as well. And then PSC Bridges supercomputer has you know, a nice set of instructions on how to run Jupyter on bridges. Now, I'm not going to be gambling and doing a demonstration on any remote machines. I trust my local computer here, so I'm going to be running everything locally today. And I wanted to give everybody a brief heads up as to you know, some details about the behind the scenes of this tutorial. It may be simpler than you expect. I hope that's not the case, but this is somewhat of an introductory level tutorial. And it's not really a Jupyter Notebook tutorial, as I've already mentioned. I should caution people that my programming skills are best described as being a Stack Overflow programmer. When I want to do something, I Google it. I usually end up at Stack Overflow. I'm not a formally trained programmer, so you formally trained programmers, please be forgiving when you look at my code. I worked at a medical center for many years, and we learned from the surgeons about the phrase see one, do one, teach one. And I kind of feel in some ways this tutorial is like that with a couple of the examples. I'm really still just learning myself, but I'm so excited about the capabilities, I'm willing to stick my neck out. But I want to refer back to the PERC hyperglyph tutorial I gave a couple of years ago before I even knew anything about pandas. So I'm still not a pandas expert, but there's much more pandas going on in these tutorials than happened in the tutorial I gave a couple of years ago. A kind woman shared that she really felt I could benefit from using pandas, and I can't disagree. Also, I should caution people that Murphy is always alive and well. When I gave my visualization workshop a couple of years ago on the TAC visualization portal, no more than 5 minutes before my hands-on demonstration, the portal went down. It had never been down before. It never has gone down since. It was down for 3 days. They have no idea why it went down. So fingers crossed that this will all go well enough. And I'm probably not going to go into much detail on visualization lessons. There are a number of excellent resources in the EXCEED community. Every supercomputer center has a visualization expert that you could locate from their websites. Okay, so to quote one of my favorite YouTube influencers, let's just jump into it. I am going to shuffle to Chrome and bring up the first lesson. So I've been working with a series of data sets that have been collected over the past few years from the High Performance Wireless Research and Education Network, HPREN. We have wildfires here in Southern California, as I'm sure you are all aware. And so monitoring weather is a really important thing that these folks do. So they have a network of hundreds of weather stations throughout San Diego County. And if I can find my link here, most of them have cameras like these. I love these cameras. I check in with them daily because one of them looks out on my house. But they also have a topology map. If we go to their main website, we can get a look at their map. So this is sort of a distribution of the network that's collecting the data that I'm going to be working with. So I'm not going to go into much detail about that, but it's a super valuable resource that's being used by the Wi-Fi project here at UCSD. They're working with first responders to use machine learning to turn around predictions of wildfire paths that have really changed the way first responders respond to wildfires. Okay, so let's see here. I think I went too far. Okay, so the types of data that's collected from these stations are comprised of the usuals: temperature, humidity, wind speed, and direction. Those are the 4 that I'm concerned with in this tutorial. So I'm just going to step through as we are, and I'm also going to go to full screen here. So maximize the screen. And I am occasionally pausing to look over at the chat to make sure everything's okay, but it'll be a little tricky. So forgive me if I'm not catching some of the comments that are appearing on the chat. So for this tutorial, we're going to be using Matplotlib. Now, Matplotlib really is the core of the visualization tools that we're using in these tutorials and most of the data visualization resources that exist for Python. We're also using Bokeh, so we'll be importing those. You'll notice that once Bokeh is loaded, it tells me Bokeh.js has been successfully loaded. Bokeh.js is the JavaScript sort of front end for the Bokeh engine. And then we're going to read in a data set that consists of temperature, humidity, wind speed, and direction for one of the weather stations. It's currently in a CSV format. We can take a look at the contents. The index is a timestamp. There's this extraneous ID column that I had included. So we can go ahead and delete that column. Let's go ahead and drop that. Now I'm going to move through this pretty quickly. All the files are available. I'm not going to go into a lot of detail with some of these basic commands like head. Anybody who knows Panda probably knows about head. And now we're just going to do a simple plot, just a default plot using Matplotlib and PyPlot. And this is what you can expect just by the default settings. So it's small. The x-axis does use the timestamp, but there's some overlap with the tick labels. The y-axis does not have a y-axis label. There's no legend. So let's do some tweaking and try to clean this up a little bit and make it a little bit more functional. Okay, so it's larger. The dates aren't overlapping. And now let's create a plot which combines all four of the different weather parameters. And this one also includes y-axis labels, titles for the individual plots, and we're color coding. Plus, we're using a subplot feature. But you'll notice that for the top three plots, I don't have the x-axis labeled. I'm only labeling. Yeah, and I'm seeing somebody would like the link to the presentation. So let me bring that up real quickly so you guys can, people who came in late can go ahead and download that one. It's a tiny URL. And it's 2019-12-DVP. Okay, so hopefully that'll work for you. Okay, so what I was doing to bury those x-axes was this command right here, just setting the x-axis visible to false. I'm not doing that for the fourth plot. And that's where the x-axis labels are appearing. Now, working with dates in Matplotlib can be a bit of a challenge. I'm still figuring it out. And as many of you who have worked with Matplotlib know, there are always many ways to skin a cat. And so some of the ways that some of the methods that I'm using to use date for an axis may or may not be optimal, but they work. So hopefully that'll suffice. Okay, now I'm going to step through the same file and go through a similar process, but we're going to extract content and run Bokeh for the first time. So we're going to create a similar interactive plot to what we had, a similar plot to what we had done previously with just Matplotlib. But this will have the interactivity that Bokeh brings. For example, we can click and drag and pan the graph. There is a wheel scroll tool, which allows me to scroll in just with my mouse wheel. Another nice feature is you can place the cursor over the X or Y axes and scroll the mouse wheel to scale the vertical. Likewise with the horizontal. Now you'll notice the x-axis, there's something odd about this, even though I was using an x time variable where I had set, I had used the to-date time function in pandas to convert the timestamp to a real pandas date time object. It's not displaying properly in the x-axis. To resolve this, we can use a command here, the x-axis type, to explicitly force it to be a date time object. Now when we rerun this, we've got the date along the x-axis. This data is relatively recent. I've downloaded it from my website just in the last day. Okay, so now let's create a combined plot similar to the previous one, but this one will also be interactive using Bokeh's interactivity. Using slightly different colors, but the principles are the same. And we can pan and zoom each one of these individually. But what if we wanted these to lock together and pan and zoom together? Well, we can do that by defining a particular parameter called the X range and setting all of the X ranges to the same variable. In this case, it's going to be this variable here. We're defining S1 in this first line, and then we're setting all of the X ranges for all 4 plots. S1.X range. So that when we run this, now all the plots should be linked. And sure enough. And then if I want to zoom in, activate the mouse wheel scroll, zoom in, and all the plots zoom at the same time. Now, since the scaling is a little off, I can individually adjust the y-axis scales for the individual plots. It may not make sense for Bokeh to link all 4 plots with this particular feature. I suppose that may be debatable, but I kind of like that little bit of independence. Okay, so now many of you may have been thinking that there's going to be more interactivity. One of the cool things about Jupyter Notebooks is that it supports IPy widgets. Some of you may be familiar with IPy widgets. They're used for sort of dashboard type interfaces. And I was really hoping to give a Jupyter dashboard demonstration, but as far as I can tell, the dashboards have been retired to the Jupyter Attic. And so we're not going to do any dashboards. And IPy widget does have an object they call a layout. And layouts are somewhat similar to dashboards, but I didn't have time to assemble a nice layout tutorial for this webinar. So hopefully this will be well enough received, so I'll have a good excuse to give a slightly more advanced webinar in the future that includes a lot more interactivity along these lines. But this example demonstrates the use of a drop-down widget so that I had in the download, the data download, I have many stations worth of data similar to this one for one of the stations. The station that this data is derived from exists on Toro Peak, which is one of the tallest peaks in Southern California. But there's almost 20 other stations that are available, and it sure would be nice if I could just use a drop-down menu to choose from and generate the same kind of plot. So let's go ahead and see how that's done. So we're defining the widget here. I'm defining the options in that drop-down menu in this options variable. The default value that's selected by default is going to be Toro Peak. And the description is number, and that's wrong. That should be station. I just noticed that, never changed that. Okay, there's some live editing there. And then we've got this function defined here that tells Bokeh what to do when that drop-down menu's value is changed. So let's go ahead and run this and see what happens. So there's the drop-down menu. It's displayed below the cell. And then I can select it, and let's pick Warner Springs. And as soon as that change occurs, and that's right, this one I'm not using Bokeh yet. This is Matplotlib, similar to the one we did just with Matplotlib and PyPlot previously. But this is cool. I mean, I can do any of these, you know, and in all honesty, some of the data that's coming in from some of these stations is problematic. The stations have either got gaps in the data, as you can see here in Warner Springs, or they're just not reading data. So forgive HPRAN for that problem. One of them's out on San Clemente Island, and it's tough to get out there and fix things. Sometimes they go down as the result of a storm. But as I select these, it appends them to the bottom of the previous plot. So that's great. That really simplifies the job of exploring the data interactively without having to manually type in names and change code and so forth. But we want to do that with Bokeh, so that's what this next cell is designed to do. Instead of Using Matplotlib, I'm basically transferring the same code that I used in the previous bokeh plot, but just taking advantage of the same drop-down menu. So let's go ahead and run this and see how that goes. Let's look at Mount Woodson. There we go. And we're using the linked interface. And that's IPyWidgets. I'm not going to go into great detail with any other demonstrations, but I did generate a, get out of here. And I do have a real simple file that demonstrates some of the IPyWidget capabilities. And I've customized some of them just to show you some of the capabilities. One of the nice things about Jupyter Notebooks is you can run all cells at once. So typically when I'm running cells, you can run cells either by clicking the run button in the menu, or you can do Shift Enter if you want to jump to the next cell after it executes, or you can do Control Enter if you want to just run that individual cell, or you can run all cells at once, and that's what I'm going to go ahead and do. Scroll back up. So widgets include things like sliders, pretty standard. You can either have an integer slider or a float slider. You can extract the value of the slider. So for example, if I've defined this slider as W, let me rerun this again. If you want to close a slider, you'll issue the w.close command. Actually, I'm jumping ahead of myself. Here's how you define a widget. You can simply issue a command, widgets.intSlider. And that'll display a slider. But if you want to do anything with that widget, you'll need to assign it to a variable. So to do that, we'll go ahead and just call it W. And then if I want to close it, I can issue the close command and it'll close that one. But let's instantiate another one. And then let's get its value. So I'm going to set the value to some number. And then we'll run that next cell and it'll extract that number. And it knows that that widget is named W. We can also set W's value to a particular value. So if I run this next one, it'll set that widget to 100. There's a number of different keys, a number of different parameters that come with individual widgets. These are the keys that are associated with an integer slider. There's widgets that'll generate text. There's widgets where you can connect meaningfully associated widgets. So this is a float text box, and this is a float widget slider, and the text box updates when the slider is changed. And let's keep on going down here. We can embed, here's the drop down that I used in the previous demonstration. We'll just keep stepping through here. In this example, this drop down generated a widget that simply prints a statement when a change occurs. And this is the simple example that I based my demonstration on. You can embed nice images in your notebooks using the image widget. And I'll be talking a little bit more about this visualization in a minute. There's budgets, there's buttons. There's a nice play control bar for animations. I won't be demonstrating animations, there's just not time for it. But animations are really powerful in Matplotlib. There's date selectors. That's a really nice feature. So I can use this if I wanted to plot a subset of the weather data. I haven't generated a demonstration like that, but that would be a natural application. There's color palettes. There's tabs. Lots of really nice interactive features. And you can also embed videos. And these are some examples of some of the visualization work, the 3D visualization work that I've done. Wind animations for San Diego County and for the entire country. Let's go ahead and play one of these. And playback is not very good. Okay, so we won't even bother. Let's go ahead and stop that. Okay, that was some work I did a couple of years ago that I am hoping to reproduce in Matplotlib. And then, so these are the cells that generated the videos above. The way videos work is you'll have to define an object. first that defines a boundary where the videos are going to play. And once you do that, then the videos that are generated will be embedded in that boundary area. All right, let's go ahead and jump to the next lesson. Okay, so I don't see any questions so far. Time looks like it's going okay. I might be a little bit behind here, but this lesson is really the one that inspired this webinar. This is work that I've been doing for the past couple of years on Twitter disinformation, exploring bot-like behavior and tweet lifetimes. The data set is a large data set, and it's about half a gig. It is 1.7 million tweets that were gathered last year by using the Twitter streaming API, searching for the hashtag Mueller report. And we have data that was gathered both during the time that Attorney General Barr came out with this summary and when the actual report came up. And there's just a mountain of data there that we're finding really, really fascinating. And Bokeh has played a very, very central role in helping us with that. One qualifier, Twitter does have very stringent terms of service. They say you can only share 50,000 tweets a day. We're hoping that because this is a pared down version, I've extracted a small subset of the tweet data from the original JSON format into a CSV and a pickle file, a pandas pickle format file. So we're hoping that the spirit of intent of this will allow them to overlook that. I think that terms of service limitation is really to keep people from making money for free off of Twitter. Let's go ahead and fill the screen again. Okay, so let's step through here. We're importing, once again, pandas and NumPy and Bokeh. You'll also see a command here in the packages import cell that sets the max column display width to a particular value. This turns out that it's fairly useful when you're displaying a lot of data widely. So these tweets have tweet text, and the tweet text may or may not wrap effectively if you don't actually use a command like that. So that's a nice little feature that I found useful for restricting the width of some of these outputs. Okay, so let's read the pickle file. It should only take a few seconds to load, even though it's about half a gig. Then let's look at the head. So this data set contains the tweet ID, the date the tweet was created at, the language, the user screen name of the user who tweeted the tweet, and when the user's account was created, user's ID, the user description, all of this stuff is pretty valuable. We care about followers count for this demonstration because we're going to be including that parameter in some of our visualizations because that plays a central role in exploring bot-like behavior. And then most of these are retweets of original tweets. But back here at the end, or off here at the far right end is where the tweet text is, and that's where all of the fun stuff happens. We picked hashtags that we thought would lead to some polarized tweets, and sure enough, somebody's asking, can any data be used? Yeah, I'm letting you guys download all 1.7 million tweets. So I'm trusting that Twitter won't mind considering that this is for educational purposes. So let's scroll down here. So we're going to extract, oh yeah, what I wanted to point out was the actual numbers. 1.7 million total tweets, 1.4 million retweets, and about 300,000 original tweets. And the time span was from April 9th to April 29th. So now we're going to extract all the retweets. Most of this doesn't involve any kind of visualization, but it goes pretty quickly. We do need to extract all of the retweets, the top retweets, and sort them in order. So we're using the pandas group by command to help with that. And I'm moving kind of quickly here because I want to make sure I get through this and still have time to cover the remaining 2 lessons. But it's fun to explore some of the content of the results. So the top retweets are listed here. The top retweeted tweet was retweeted over 18,000 times. But you'll see a column here that has the column name 0. So we want to rename that column. Let me make sure we've done that. Where are we? I'm getting ahead of myself here. So we want to rename that column to retweet count. And we'll do the same kind of thing with the top retweeters. So For example, what we mean by top retweeter is all the users in this data set that tweeted the most. So the Twitter account Alpha Omega Ya tweeted 766 times during that 20-day span. And likewise, the top retweeted are those user accounts that were retweeted the most. Speaker Pelosi, Representative Swalwell, Sarah Carter, you'll recognize those names, I'm sure. Okay, so the first thing we were doing in our research was to generate some real basic plots using the BIND, frequency counts of tweet activity. We counted the number of tweets every 5 minutes. Twitter has a limit of 50 tweets per second. If you are collecting with the streaming API and there's more than 50 tweets per second for the hashtags you're collecting on, you'll only get 50. We almost met that. We got up to about 30 tweets per second for some of this data. So here's an example of what these BIND plots look like for the entire data set. Here we're setting the X limit, the limits of the X axes. We're including a grid. You'll notice that there's very, very little activity on the Mueller report hashtag from April 9th to April 18th until the summary is released. And that's, no, that's the Mueller report itself, that's right. So the day before there was anticipation, and then there was a gradual exponential decay. Now these individual dips are the nighttime, basically, for North America for the most part. So when you see these dips, they're not anomalies, but you will see this little spike right here, and we'll talk a little bit more about that in just a second. A little spike there, and that's not an anomaly. I'll tell you who that is in just a minute. So let's plot a couple of individual tweets and look what a typical tweet looks like. So I'm only going to plot the top 2 retweeted tweets. The first one, this was the one that was retweeted the most, starts off really big and an exponential decay, goes through nighttime, gains a little bit of life the next day, and then dies out. But the second tweet is really one of the most interesting in the entire data set. It has a similar beginning. In fact, we may not have gotten it. No, actually, we did get this earlier, so I'm not sure why the x-axis is showing up quite there. But around April 21st, this gained a second life. And the individual who caused that activity, we don't know. We're not really even sure whether that's anomalous or not. It seems rather extreme. So that's one of the limitations we're faced with in a Matplotlib plot. It tells us some features of the data, but not a lot. To give you an idea of the distribution of these top tweets throughout the entire data set, we can generate a combined plot of all these bin plots and let Matplotlib generate the color palettes for us. You'll see that orange one right there, goldish orange. That's the one that is the second most retweeted tweet in the data set. And like I say, we'll get to that in just a minute. Another method that was developed by some folks up at University of Washington under Kate Starburd's direction was what we're calling a cumulative timeline. And this is a method in which we simply use an integer increment for the y-axis. So as a new retweet comes out, we simply increment a dot in a scatter plot. And this shape, the shape of this curve is pretty typical of a regular tweet. There's a little dip there, that's a nighttime dip, and then it comes back again. And then this waning means that very, very few retweets occur over a period of time, and then that tweet basically dies out. But if we look at this next one, you see a similar kind of behavior here, and then there's a inflection point, and it just takes off again. It has a big second life right before it was ready to start dying off. That even goes through a couple of nights, and then it finally ultimately dies off. And we'll learn who that is in just a moment. So let's try a different method. This method uses follower count to reveal additional information by scaling the individual dots in the scatter plot. And follower count really shows something's going on in that point of inflection. And so we can continue on and create a different method where we're combining those two plots so we can see the activity And unless I zoom in, you can't really tell, but that large dot obscures a lot of the data behind there. So we can combine plots and get a better idea what's going on, but we still aren't able to get a lot of the details about that activity that we really want. So let's turn to bokeh. Now I've got a flag here that will allow me to choose either plotting to an HTML page or outputting to a PNG. Now, some of the color coding that I'm going to be using in these plots was generated by calculating bot scores for the top 10,000 users in the data set. I've already generated that file, and I'm simply going to import it as a CSV. And now I'm going to generate some bokeh plots. And I'm getting some feedback on data visualization. You know, to be honest, you kind of have to talk about what's motivating behind the visualization methods. So I apologize if this is maybe too much about my research, but I'll note that. So when these images are generated, they get loaded into my default browser in Safari. And so now we're in bokeh. So this is the most retweeted tweet. With bokeh, we can pan. We can use the wheel scroll capabilities to zoom in. Now the color coding in these dots means that if it's green, I didn't calculate the bot score. If it's blue, it has a low likelihood of being a bot. If it's red, it has a high likelihood of being a bot. Now here's the second tweet, the one that has the point of inflection. And bokeh has a really nice hover tool that shows if you add metadata to the plot itself, simply by hovering over that dot, you can get a lot of useful information. So we can see that the user who generated that new life of the tweet is our president, Donald Trump. And you can see the content of that actual tweet. The tweet was by Doug Collins, talking a little bit about the Mueller report. Okay, but these plots don't really tell me much about bot activity. We don't see a lot of red here. We see a little bit of red up here. So let's go ahead and plot these by color coding with bot scores. And then by doing that, we get this. There's a lot more red. Yellow also means a much high likelihood of being a bot, but not as high as red. Now, if we really want to see what's going on in that little point of inflection, we can click and scroll with the mouse wheel over the y-axis, and it will really stretch things out. Oh, I think it just loaded one of the, there we go. So we can really stretch things out and drill down and see exactly who's doing the tweets and where with the hover tool. Okay, so I've left as a third exercise a method for visualizing tweets that demonstrate users who tweet multiple times, but I'll leave that as an exercise offline. Okay, so let's go to the next lesson, and I want to reiterate how a lot of these visualizations were in the effort of creating a Cornell Virtual Workshop tutorial. Let's go to lesson 3. Okay, so this data set that we're using for this demonstration is the entire history of Major League Baseball. It's a freely available data bank that you can download. I've already generated a number of these. I've already run through a number of these cells to pre-process, so we don't have to take the time to step through them, because some of them do take some time. But we first read the data in. We're reading all data in from a series of CSVs, and then we're using the glob function in Python to read all of the data in and create a data frame. And we can look at that data frame. Now, one of the things that we do in this lesson is we filter the data, because we need to generate all of the values of singles that were hit from the entire number of hits minus the number of doubles and triples and home runs. So we've done that in this step. And then we leave as an exercise learning something about the slash line, which is a feature in baseball that talks about correlations between hitting statistics. We're using group by operations, but I'm going to move on down here and jump right to this Seaborn question. I think is just an outstanding example of how Seaborn can be used to look at correlations in hitting statistics throughout the history of baseball. So what we're doing here, although the axis labels are rather small, the left column is singles, one base hit. Next column is doubles, then triples, then home runs, strikeouts, base on balls, runs, and RBIs. Likewise in the Y column, so there's a sort of a mirror resulting from this kind of plot. But one of the first things that really stands out, or one of the things that if you know as a baseball statistician, there is usually a high correlation between strikeouts and home runs. And that's this scatter plot right here. Now, if we look at the legend is colored based on decades. So the lighter colors are the older decades and the darker colors are the more recent decades. And even though there's a little bit of zigzagging in there, for the most part, it's a pretty distinct linear correlation between strikeouts. Now, that's not the case for strikeouts with doubles. It's not the case with many others, and there's even a negative correlation between strikeouts and singles. So Seaborn makes this kind of plot makes it very, very easy to just spend time exploring a lot of details that you can't get at easily any other way. And we're using a feature called pair grid. That's what Seaborn provides to make this a little bit easier to generate. Now, another example of what Seaborn can do is heat maps. This is what we're calling correlation of hitting statistics, and we're normalizing the numbers, and we're using the annotation attribute to display the numerical values that are correlated with the color code here to give you a similar idea as to the correlations between different types of batting statistics. Okay, so there's a lot more to this lesson, but that's really the extent of the visualization. Once again, I want to give hats off to Chris Myers. This is really all Chris's stuff. He's got another really nice example down here in which he's using Matplotlib's annotation features to call out different events in the history of baseball by adding these little call out text strings to the plot. And that's done here in the code right here. Okay, so the second to the last lesson that I'm going to be demonstrating is how to use Bokeh to make a Network X graph a little bit more interactive. Be careful not to let that drop down. Okay, here we go. Okay, so this is a real simple one. It's already mostly pre-processed. Network X has some graph visualization capabilities, but zero interactivity, and it takes a lot of effort to really get a decent graph, and it takes a long time. Network X is a lot slower in visualizing networks, visualizing graphs than something such as Gephi. Gephi is my go-to tool for generating graphs quickly and providing interactivity. Now, somebody's asking what's the best place for a go-to primer on Seaborn. Honestly, my inclination would be to point you to the Seaborn site. I actually don't have a list of links that I can point you to give you a good idea, but I'm going to get a little bit more into Seaborn in just a moment. So let's step through this. So yeah, Network X doesn't give you any interactivity really, and Bokeh does. So getting Bokeh to work with Network X is fairly straightforward too. I've already pre-generated an adjacency list, and this comes from another Twitter data set that was collected on the hashtag climate change a year or so ago. And the adjacency list simply consists of all users who tweeted other users and how many times they tweeted those users or retweeted those users. So believe it or not, these numeric names here are actual Twitter accounts. You'll see here the Target, Greenpeace, and UNFCCC. That makes a little bit more sense. These numeric accounts are probably bots. Now let's go ahead and create the network from the adjacency list. And we can use NetworkX to generate the network visualization, and that's what this is. Now, I'm not generating the entire adjacency list of all of the activity. What I had to do is set a minimum threshold of at least 5 retweets of another user before you're included in this visualization. And it still creates a fairly complex visualization, which took about 2 minutes to generate. Of course, we all have access to supercomputers, so we can certainly tweak those thresholds to create a much more complex visualization, but it's really, there's not much I can do with this visualization. I'm going to, oh, it's not letting me open it in a new tab. That's interesting. So I'm going to take a closer look so we can see that the nodes in this graph are actually labeled the user's names. But it's such a complex graph, and I'm zoomed out so far that you can't actually see the text that's overlapping them. But let's see what Bokeh can do. Now, Bokeh takes a little bit of time to generate this graph. So I can just toggle and bring it up. In fact, I think what I'm going to do is just stop this so it doesn't overwrite my climate change file. Okay, so here's the Bokeh version of that same network. Now, the node size is the same for all of the nodes, but with my wheel scroll tool, I can scroll in quickly, find out who the users are who are really central to some of these nodes, central to some of these clusters, such as UNFCCC. This one, I think, is Paul Dawson. Yeah, Paul is a well-known climate scientist. So this is the kind of interactivity that would be really nice to have with NetworkX. And there's a lot more that we can do. Oops, I didn't want to do that. Oh yeah, so I've zoomed in too close. Bokeh has a nice reset feature where I can just click reset and it'll jump me back. Yeah, so the next thing I might want to do is use the weights column in the adjacency list to define the edge thickness or the node size. But we won't be doing that in this lesson. Okay, now the last thing that I want to show you before we're done here is using Seaborn to create a heat map of weather data. It's not quite the same data that we were using previously. Somebody's asking a question. At this point, do you recommend that someone who's just starting or planning to teach a class focus more on Bokeh than any other program? Boy, I'm not sure I would recommend that. There's a number of powerful tools out there, but Bokeh would be certainly one that it would be conspicuous if it were left out. But there's lots of tools, and like I say, there's many ways to skin a cat. And I've seen people complain that Bokeh doesn't provide the capability of supporting large amounts of data. Some people think D3 is a little bit easier to work with. So it's hard to say, but I would say you can't hurt. Okay, so a few years back, I created this visualization of weather data in San Diego County. But the tool that I used was, believe it or not, PHP in the GD graphics library. I teach PHP and MySQL, and it was the language that I knew best back then. And the only content that I actually used to PHP 4 was for the plots themselves. So what we're looking at here is all data for temperature, humidity, wind speed, and direction for 4 years, for 3 years, 2014, 2015, and 2016. The legends are on the left. The ribbed effect is because of the daily weather cycle. So I like that effect itself. And if we zoom in even closer and closer and closer, we can get a sense that this is a heat map. Let's get real close. So each one of those little dots is virtually an individual pixel corresponding to a particular dot on the heat map. Okay, so I wanted to create something similar to this using Seaborn. Now, this was a lesson I put together just at the last minute, and so I haven't really refined everything quite as well as I would have liked. Oh, and by the way, I'm using an IPy widget to embed this image in my notebook. But let's go ahead and read in the CSV files for this particular data set. We can learn a little bit about the information of those pandas data frames. We can look at the head content. Now this data is a little bit different. This is data in which each row corresponds to a point in time and the column corresponds to a station. We can plot the data just to make sure that it is functional. And now let's try to create a simple plot using Seaborn's heat map. And that's what that is. Now the y-axis label probably should be date, and this is oriented vertically and not horizontally. The black lines correspond to gaps in the data. There are various ways to handle 0 values or not a number of values. We haven't done anything fancy to handle those in particular. But I did at least want to say that Seaborn has some really nice capability in working with color palettes. So the default color palette might work for this particular example, but if we wanted to use a different kind of color palette, we can use either one of the defaults provided by Seaborn, where we can vary parameters such as luminosity and saturation. We can define a variable number of increments in the palette. And so with this new palette, let's generate the same plot, and we'll make it bigger. Takes a few moments. Probably, there we go. Okay, so, and another nice feature, as I might have mentioned before, in Jupyter Notebooks, if you click the left side of a cell near the output area, it'll collapse that window. One thing to be on your guard for, a lot of the work that I do in a Jupyter Notebook just outputs data to track whether I'm getting the results that I need, you know, print statements. But I've made the mistake of not checking and scrolling down and not observing errors that appear at the bottom of this output window. And if nothing else causes any problems, you can make the mistake of proceeding thinking that everything is fine. So it's always wise to make sure you expand that output window just to be safe if you've got outputs that are gonna, if you've got cells that are gonna rely on the outputs of this cell. So here's the heat map with a different color palette, much larger. And with that, I hope I didn't go through that too fast, but we're right at noon. And I can see a number of people have been posting to the chat. Have I missed anything? Does anybody else have any questions? I will be following up with a PDF of my slides. I did not get those uploaded in time. I'm happy to email anybody with additional information. And as I said before, I will send a link out to the recording once it's online. Now, people are asking, where do I go on the Exceed site to mark my attendance? In all honesty, I have not figured that out myself. So I have seen that people are doing it. My guess is that if you simply go to the link to this webinar on the course calendar, there should be a place where it's fairly obvious. Thanks for the link on that, Marty. Yeah, Marty's explaining it right there. Okay, so I know many of you out there are already doing some pretty advanced stuff with data visualization and Python. Hopefully this wasn't too simplistic, but my guess is many of you are like me. You're self-taught in programming and you just want to do some visualizations, and some of it can be pretty daunting. So I'm hoping that this tutorial has helped, and I look forward to the opportunity to do some more advanced stuff with you. Thanks very much.